Okay, this is renal physiology. The primary purpose of forming urine in the kidneys using this nephron is to maintain homeostasis by really regulating the volume and composition of blood. There are several waste products that are found in the urine, and basically how urine is formed is through three different processes. Filtration, which occurs in the renal corpuscle. And this is the renal corpuscle here. And reabsorption, and the main reabsorption occurs in the proximal convoluted tubule, which is right here. And we also get some reabsorption in the nephron loop. And then also secretion, and secretion occurs mainly in the distal convoluted tubule, which is right here, and maybe a little bit of secretion in the collecting duct, which is here. We'll start by looking at filtration. The renal corpuscle is the only place in this nephron where filtration occurs. And the filtrate is coming from the blood. So as blood enters into the Bowman's capsule and into the glomerulus, fluid is pushed out into the space surrounding that little capillary bed. And then it's called filtrate. Now this filtrate contains water and ions like sodium, chloride, calcium, a bunch of good stuff that we actually want to keep. Also solutes like glucose and amino acids. All right, so we want to keep these things, but it looks like we're trying to get rid of them and put them in the urine. Things that stay in the blood and then will exit out through the efferent arteriole are things like red blood cells, white blood cells, platelets, plasma proteins. Okay, and these things we're not going to, they're too big, and then they can't get out into the filtrate, so they stay in the blood. Okay, once the filtrate moves into the proximal convoluted tubule, it is then called tubular fluid. It's no longer called filtrate. Once it's in the proximal convoluted tubule, most of the absorption will occur there. So we see these little arrows here. We have the reabsorption of almost 60 to 70% of that original filtrate. So whatever gets filtered into this space and ends up in the proximal convoluted tubule, 60 to 70% of that is going to get reabsorbed back into the body. And it gets reabsorbed back into the interstitial fluid, or the fluid in the tissues surrounding the nephron. Okay, 99%, when we see this arrow, we see that 99% of glucose and amino acids are reabsorbed here. So those are obviously very good things that the body wants to keep and does not want to urinate those out. So we're going to reabsorb those in the proximal convoluted tubule. And then actively, the proximal convoluted tubule will transport sodium, potassium, magnesium, bicarbonate, and these things will get actively transported back into the interstitial fluid. There is a minor amount of secretion, and secretion is where substances will move from the interstitial fluid into the tubular fluid, but most of the secretion doesn't occur in the proximal convoluted tubule. All right, now what is left of that tubular fluid then will flow down into the nephron loop, previously known as the loop of Henle. And we have a descending limb and we have an ascending limb, and fluid will just flow through this whole loop. In the descending limb, of whatever is left, half of the water that did not get reabsorbed in the proximal convoluted tubule will get reabsorbed here. Now I should go back and show you that we do have water reabsorption in the proximal convoluted tubule, and that just makes sense. All of the solutes that are diffusing into the interstitial fluid causes a concentration gradient where there's a high concentration of solutes in the interstitial fluid, and then water would just follow naturally through the process of osmosis. So much of the water is reabsorbed in the proximal convoluted tubule, but whatever is not absorbed there will get absorbed here in the descending limb of the nephron loop. Now this descending limb is not permeable to solutes. So things like sodium, potassium, chloride, magnesium, those things are not going to be able to be reabsorbed in the descending limb. In the ascending limb, we find that in the ascending limb of the nephron loop, it is impermeable to water. Okay, and solutes have a tough time getting reabsorbed there too. However, we do have active reabsorption of sodium and chloride. All right, so sodium and chloride are able to be actively transported back into the interstitial fluid, back into the body. About 2/3 of whatever is left from the original proximal convoluted tubule will get reabsorbed. So 2/3 of the sodium and chloride that's remaining will get reabsorbed here in the ascending limb. Then we get to the distal convoluted tubule here, and a lot of what happens in the distal convoluted tubule is called secretion. Secretion is where we have movement or transport of solutes from the peritubular fluid into the tubular fluid. Okay, well, we've been calling this the interstitial fluid. This is also called peritubular fluid because it is surrounding or peri the tubule. So out here, there may be things that did not get caught, did not get filtered in our glomerulus. And so we have certain substances that will then need to get secreted into the distal convoluted tubule so that it can end up in the urine. Anything undesirable is going to get secreted back into the distal convoluted tubule from our bodies, from the interstitial fluid, so that we can get rid of it in urine. And these might be ions. They could also be drugs that were missed in the filtration process, different things, that toxins, things that were just missed in the filtration process that we want to get rid of. Finally, then, this tubular fluid moves from the distal convoluted tubule into the collecting duct. In both the distal convoluted tubule and the collecting duct, they are both sensitive to a hormone called aldosterone. And aldosterone will bind to receptors on both the distal convoluted tubule and the collecting duct's membrane, and will open up gates to allow for the reabsorption of sodium back into the body. And we all know what happens once sodium gets reabsorbed back into the body. Because of the concentration difference in solutes, then water is surely to follow. This is controlled, of course, by the juxtaglomerular apparatus. And the juxtaglomerular apparatus is where there are cells in the distal convoluted tubule that touch the cells of the afferent arteriole. Okay, and that's because this nephron really folds over on itself, so the distal convoluted tubule is touching the afferent arteriole. And then those cells make up the juxtaglomerular apparatus. And this apparatus is going to be sensitive to blood volume. Okay? If the blood volume is low, so if the amount of blood coming into the nephron is low, then a hormone called renin and a hormone called erythropoietin will be released. Renin causes us to be thirsty, but it also will convert to angiotensin II, which in the long run causes the adrenal cortex to produce aldosterone, and it will also cause the posterior pituitary to produce ADH. In any event, the result is increased water absorption in the nephron, in the distal convoluted tubule and the collecting duct. Okay, well, we have 180 liters of filtrate produced every day. And of that, more than 99% will be reabsorbed by the time we get to the collecting duct, and the rest of it will end up in the substance called urine. So once the tubular fluid hits this collecting duct area, we now call it urine, and the urine will start to head out the kidneys through the papillary duct, and then through the minor calyx, the major calyx, the renal pelvis, and then the ureter, and head down to the bladder. This ends renal physiology.